Hey everybody, these are the notes on section 3.2 about relations and functions. Our goal is to identify functions, find the domain and the range of relations and functions. So we're going to start with some definitions. We're going to work through some examples and non-examples of functions, and then on Monday we'll be ready to actually work with the different notations and so forth regarding functions. Okay, so first definition, a relation is, it's a set of ordered pairs. And now this set of ordered pairs can come to you in several different formats, okay? It could be actually a set of ordered pairs written like this. Okay? Or you could have a table of those ordered pairs, or you could have a graph of those ordered pairs. But a relation is just a list of x and y values that are related to each other. Okay? The domain is the set of all the x values in that relation. Okay? And it's only the x values. The range is the set of all the y values in the relation. Okay, there's a special type of relationship called a function. And we're going to define a function as a relation in which every domain value, remember that's x, is paired with just one y value or range value. And we'll say exactly one range value. Okay. A quicker way of saying that is for every x there is only one y. Another way to think of it is the x values cannot repeat. Okay? All right, I want to talk about examples that are functions and non-functions. All right, the first example I want to give you is think of a scoring system at a track meet. So let's say your first place finisher gets 5 points. Your second place finisher gets 3 points. Your third place finisher gets 2 points, and your fourth place finisher gets 1 point. Okay? So for every value, or for every place that you finish, there's only one type of point that you get for that. Okay? So in a table format, it might look like this. Okay? First place gets 5 points. Second place gets 3 points. Third place gets 2 points. And fourth place gets 1 point. Okay, so that's your table for the data. And note that every x value only gets one type of point. Another way you can draw it is with what's called a mapping. This might not be as familiar to you. What you do is you put your x values and your y values in sort of a bubble, and then you draw how they get from one to the next. So here are your x values, 1, 2, 3, 4. Here are your y values, 5, 3, 2, 1. And you can write them in any order, but then you draw, 1 gets mapped to 5, 2 gets mapped to 3, 3 gets mapped to 2, and 4 gets mapped to 1. So again, you can see each x value has just one y value. Lastly, a third way you can show that exact same data is through a graph. If this is what place you finished in the race, and these are the points you received, so first, second, third, fourth place, and up to 5 points. So first place got 5, second place got 3, third place got 2, and fourth place got 1 point. There is a discrete graph of our data. Okay? And these things are all functions. Now, let's think of a non-example, and we can use our track meet example, sort of. What if you were at some crazy track meet, and this could never happen, but what if first place got 3 points and first place got 6 points? Doesn't make any sense, really. And let's say second place got, I don't know, 9 points, and third place got 12 points. Okay? What you notice here is that first place got paired these x's are paired with 2 different y values. So that's not a function. Okay? First place can't get 3 points and 6 points. It doesn't make sense. Okay? In a mapping, a non-function might look like this. Here are your x values. Here are your y values. Y gets mapped to 3 and a 6. 2 goes with 9, 3 goes with 12. So here, that cannot be a function because that y value is getting paired with or mapped to 2 different y values. Lastly, on a graph, if you were to graph this data, if this is your x and your y values, one got paired with 3 and with 6, 2 was paired with 9, 3 was paired with 12. Okay, you can see that this x value right here has 2 separate y values. That's no good. So in all of these situations, x is paired with 2 y values. Those are not a function. All right. There's a way you can look at a graph to tell whether or not something is a function, and it's called the vertical line test. Okay, VLT down here. And here's how it works. This is a test, and it's used to determine whether a relation is a function. If a vertical line crosses a graph of a relation more than once, the relation is not a function. So for instance, look at this right here. If I draw a vertical line through this data, it is going to cross this function or cross this relation in 2 places. That shows that it's not a function. So let's continue our definition here. It says, if a vertical line crosses the graph of a relation more than once, the relation is not a function. Okay. And again, you can see that on this graph right here. If I were to draw a vertical line when x equals 1, it would cross that function 2 times. It would intersect at these 2 points, showing that there's 2 values of y for that 1 value of x. So that's not a function. Okay, on Monday, what we're going to do is we're going to practice displaying these functions in 3 different ways, in a table, in a graph, and in a mapping, and determining whether or not they're functions. Okay? You don't need to work on this over the weekend. We'll do this Monday in class. Thanks, everybody, and have a great weekend.